maybe you graph your polynomial and you have those x-intercepts. So we say that the roots of p of x equal to 0 are, we call them zeros of the p of x, and they are x-intercepts of the graph of p of x. Of course, that's the case only if they are real, because if your zeros are complex numbers, then you cannot represent them on the x-axis, so they don't appear as x-intercepts, right? So let's see two examples. Example 1. Let's suppose that you have the polynomial x cubed minus 2x squared plus x minus 12. And they will ask you, is x equals 3 a root of p of x? In other words, if you substitute x equals 3 in this p of x, will you get 0? Well, let's see. So p of 3 is 3 cubed minus 2 times 3 squared plus 3 minus 12. Well, guess what? If you do the calculation, you will get 0. So you say yes, x equals 3 is a root of p of x. If you don't believe me, you can do the calculation yourself. Another example, example number 2. And they will say find the zeros of p of x equals x squared minus 4x plus 53. Alright, zeros means take what you're given and set it to 0. This is a quadratic equation now that I have to solve. So I'll go ahead and find the discriminant, which is b squared minus 4 times a times c. Calculating this gives you minus 196. Therefore, no real solutions, but we learned that, alright, it has complex solutions. So 196 times I squared, that's the way we write the discriminant. So then x is negative b, so negative the minus 4, plus minus the square root of 196 I squared, divided by 2a, so 2 times 1. That returns solutions that are going to be 4 plus minus 14i divided by 2, or 2 plus minus 7i, right? So this is your solution. We talked about roots and we talked about zeros. The last thing we need to talk about in this subchapter is factors. So let's address the factors. Right here, factors. We could write down that x minus a is a linear factor, and we call it linear factor because x is raised to the power of 1 here, right? Is a linear factor of p of x. If x minus a is a linear factor of p of x, we could write p of x as a product of this factor times another polynomial. So it could be expressed this way. And I'll give you an example. And this one will be example number 3 here. Let's suppose that you have to factorize 2x cubed plus 5x squared minus 3x. Well, the first thing you can see is that all of the terms have x involved, so you can write it as x 2x squared plus 5x minus 3. And then you can factorize this. This will be done. I mean, I can show you the way, but you probably know, but let me show you. So we will do this by splitting the middle term, so 2x squared, and that 5x, I'll write it as 6x minus x minus 3. That will be, I'll do it now in groups, 2x, x plus 3, minus 1, x plus 3. So I first grouped the first two and I got this. Now I will group those two and I'm getting that one. And now last step is to just write it x plus 3 times 2x minus 1. So now it's fully factorized. And you can see, let's say, you can see that 2x minus 1, or let's say x plus 3, or x minus 0, so x. Those are linear factors of the polynomial. Another example number 4, if I'm not mistaken. They might now give you the zeros and they will ask you to find all possible polynomials. So the question might go like this. Find all real cubic, so that means the highest degree of the polynomial is a 3. Find all real cubic polynomials with zeros, so they give you the zeros. 1 over 2 and negative 3 plus minus 2i. So you have 3 solutions. For sure, if the solution is 1 over 2, we could go ahead and write our polynomial as x minus half, because one of the solutions is the half, right? Times x squared plus bx plus c, because it's going to be third degree. You could have a multiplier a out here. I'll just put it here. There. And now let's see what this could be. So we have used the fact that we know that one of the solutions is half. Now we also know that the other two solutions are negative 3 plus 2i and negative 3 minus 2i. And we're going to use what we have learned about the sum of the roots in a quadratic equation. The sum is negative b over a if the equation is in the form of ax squared plus bx plus c. I'll just remind you of that. So the sum of the roots is this. And in our case, a is 1. You can see I didn't choose to have an a here. I just wrote 1. So I'll just write that the sum of the roots is just going to be negative b without the a here. And we learned that the product of the roots, it is equal to c over a if your expression is again in the form of ax squared plus bx plus c. But again, in this case, our a is 1, so the product of the roots will just give us the c. So what are those sum and product of the roots? Let's try and find them. So the sum of the roots is negative 3 plus 2i, one root, plus negative 3 minus 2i. And the product of the roots is negative 3 plus 2i times negative 3 minus 2i. So the sum of the roots, you can see here that is actually negative 6. Thus, b is 6. And the product of the roots is 9 plus 6i minus 6i minus 4i squared. And if you do this calculation, you will see that this is equal to 13. This cancels out, that becomes plus 4 because I squared is negative 1. So you can say thus c is 13. So now a possible polynomial that you could have is a factor a times x minus half times x squared, x squared plus 6x plus 13. There you go. So we found all real cubic polynomials with zeros, half, and -3 plus minus 2i. We've done this by splitting the polynomial into a linear factor, you can see it here, and a quadratic factor. We did this because we knew what is the linear factor. They gave us that one of the zeros is a half, and we also knew that you have a quadratic factor with the two solutions being -3 plus minus 2i. I will give you one more example. So let's go here and write example 5. So what if they say find all real quartic? Quartic means fourth degree polynomials with zeros. And the zeros, they say 2 plus minus square root of 3. So you have 2 plus root 3 or 2 minus root 3. The other one is 4. The other one is 0. Well, then you can write your polynomial p of x as a times x minus 4, because 4 is one of the solutions, times x minus 0, because 0 is the other solution. But of course we don't write x minus 0, we just write x, and I will just put it here, a times x minus 4. And then up to now we have a second degree polynomial, right? So we're missing the quadratic part, so I'll just write it again as x squared plus bx plus c. And as we did right above here, where we said the sum of the roots and the product of the roots, it's the same here. So the sum of the roots will give you your negative b, and the product will give you the c. And the roots are 2 plus root 3 and 2 negative 3 and negative root 3, and the product would be the same here, right? Very good. So you can see that the sum of the roots is 4, thus b is -4, and the product of the roots is equal to 2 squared minus root 3 squared, which is 4 minus 3 is 1, so we can write c is 1. And therefore the polynomial can be written as a factor a multiplier, times x minus 4, x squared minus 4x plus 1. Okay? So to practice, you need to practice this a little bit more than the other parts. I would like you to go ahead and do exercise 5C on page 115 onwards. I don't know if it extends on the next pages. And could you please do question 3, question 5, and question 12 to practice.